In this video, we're going to take a look at section 1.6 on miscellaneous equations. Sorry, I wasn't quite ready to get started. All right, so in this section, we're just going to see lots of various different types of equations, and we'll just talk about the different methods that are effective on each type. The first type of equation we have here are polynomial equations. And the method that's most effective for these at this point will be to get it equal to 0 and then factor it as much as you possibly can. And then you set each factor equal to 0, much like we were solving quadratic equations in the previous section. So this one's already equal to 0. So I'm going to try to factor this. Now, whenever you're trying to factor a polynomial with 4 terms, the method that is most likely to work, is, at least at this point. Now we're going to be dealing with polynomial equations in chapter 3, and this method probably will not work on most of those problems, but for this section you should try factor by grouping. And that's where you group the first two terms together. So 5x to the third power plus 20x squared. And then group the second two terms together, and we talked about this in the last video. You leave the minus sign with the x inside the second group. And you always start with a plus sign between the two groups. And then you factor out the common factor. So the common factor in the first group would be 5x squared. And that's going to leave me with x plus 4 from the first group. The second group actually does not have a common factor, but we want these to match. So I don't want them to be negative. I want them to be positive. So I will factor out a -1. And that'll leave me with positive x and positive 4. And now these parentheses match. And that's really essential for factor by grouping to work. And so an issue that some students have is that they've never seen an example where factor by grouping is not working. So they don't recognize when they've reached a dead end, and either they made a mistake or that process just doesn't work for that particular problem. And the way you can tell if it's working or not is right here. If this does not match this, factor by grouping is not working. Either you made a mistake or you'll have to use a different method to solve the equation, which, like I said, we'll learn later in chapter 3. But as long as these two match each other, you can keep moving forward. Again, it's like you have two terms here and they have this common factor of x plus 4. So we're going to factor out the x plus 4. And that's going to leave me with 5x squared from the first group minus 1 from the second group. And so now I've factored it. Sometimes with the x squared factor, you might be able to factor it down even further. And if so, you should go ahead and do that. But with this one, it's not going to factor any further. We have 5x squared minus 1. There's nothing I can do to factor that anymore. And so since I've factored as much as I can, I will now set each factor equal to 0. So we get x plus 4 equals 0, and we get 5x squared minus 1 equals 0. And then we solve for x in each case. So for the first case, we just subtract 4 from both sides. We get a pretty straightforward answer there. This one's not going to be so straightforward. It is a quadratic equation now. It didn't start off quadratic, but now that we've factored it, this particular factor leads us to a quadratic equation. And so this one we're lucky enough to be able to solve by just getting x by itself. We'll add 1 to both sides. So we get 5x squared is equal to 1. Then we divide by 5, and I'll just continue up here. We get x squared is equal to 1/5. And then to cancel out that power of 2, we take the square root of both sides. And we learned about this situation in the previous video in section 1.5. First, you have to make sure you put a plus or minus on this result whenever you take the square root of both sides. And then we're going to apply the square root to the top and bottom of this fraction. And then because we have a square root in the denominator, we have to rationalize. So we'll multiply square root of 5 to the top and bottom to rationalize that denominator. And we end up with x equals plus or minus square root of 5 over 5. And so we have 3 answers in this case: -4, positive square root of 5 over 5, and negative square root of 5 over 5. I did kind of take a shortcut here, so just to remind you, square root of 5 times the square root of 5 is the square root of 25, which is how I got 5. And here you just multiply these together. That's how you get square root of 5. All right. So that's one type of equation that you'll have is polynomial equations. And the method you should apply to those equations is to factor. Set it equal to 0, factor it, and then set each factor equal to 0 to get your solutions. The next type of equation we have is a square root equation. So here we have the square root of x minus 5 equals x minus 5. Now sometimes on these you can kind of guess at a solution, but you really want to follow the process because there could be more than one. So even if you find one that works, there's no way to know if that's the only solution. So you would need to keep guessing just to make sure there's no other numbers that would work, and you'll never know if you've found them all or not. And so what you want to do is follow this process I'm about to outline for you. The first step is to get the square root by itself, which for this problem is already the case. So square root's already by itself. And just like we talked about in the last problem, square roots cancel out with powers of 2. So we already have a square root here. If I want to get rid of that square root, which I need to do if I'm trying to solve for x, I'll raise it to the second power. Powers of 2 cancel out square roots. If I do that to the left-hand side, I have to do the same thing to the right-hand side. So on the left-hand side, what's going to happen is the square root cancels out the power of 2, and we just get x minus 5. On the right-hand side, we've talked about this in some of the previous videos for chapter 1. You cannot distribute the exponent of 2 when you are adding or subtracting. You cannot distribute it to terms. So what we have to do here is take the x minus 5 and multiply it to itself twice. So that's the definition of raising something to the second power. You want to multiply it to itself twice. And by writing it out like this, it becomes clear that what we have to do is FOIL. So we do first outer, inner, last. So we get x minus 5 equals x squared minus 5x minus 5x plus 25. I know I'm going through that kind of quickly, but I assume you're okay with the FOIL process. If not, send me an email if you need some help figuring that out, and I'll get back to you that way. If you're one of my students, if you're just if you're another student in another college at with another teacher, check with your teacher if you need the details for how we got this. After saying all that, I probably should have just took the time to explain it. It would have taken the same amount of time either way. Then what you should notice after you FOIL is that you end up with an x squared term, which means this is now a quadratic equation. So with these square root equations, they can either work out to be quadratic once you start, getting rid of the square roots, or they can end up being linear, which is where you have just x to the first power. And it's important to pay attention to that because depending on which one you end up getting, I said that kind of funny. Let me say it this way. I don't want to say depending because that's saying it the same way. And whichever one you end up getting dictates the way you have to finish out the problem. So it's important to recognize, am I getting a quadratic equation or am I getting a linear equation? Because that will determine how you proceed from there. So with quadratic, we want to get it equal to 0 and then either factor or use the quadratic formulas, the most likely options that we'll have to consider. So I'm going to make this side equal 0 by subtracting the x over here and adding 5. I'll just get rid of both of these at the same time, move them over to the right-hand side. That zeroes out the left-hand side. So we get 0 equals x squared. Then I'll combine all these x's together, and that gives me minus 11x. And then I'll add these two numbers together, and I'll get plus 30. And so we're going to try to solve this by factoring. We can't solve it by getting x by itself because there are two x's in the equation. We talked about that in the previous video as well, section 1.5. And you'll realize that section's really critical because we will be seeing quadratic equations throughout the entire course. So it's really important that you get the hang of solving these kind of equations. They will be very frequent. Either you can get x by itself, taking the square root of both sides at some point, if there's only one x in the equation, which is not the case here. Or you could solve it by factoring, which will normally be possible for a lot of the problems that we will see. But if that doesn't work either, you can always use the quadratic formula. Right, so this one will factor. We can use the shortcut because a is equal to 1. So we just need to find two numbers that multiply to 30, add to negative 11. Those two numbers would be negative 6 and negative 5. So those will be my two factors. Excuse me. And then we set each factor equal to 0, just like we did in the last problem. Whoops, I kind of skipped to the answer there. Minus, and that's pretty common to do, and that's fine if you want to do that. A lot of students don't bother writing this particular step because they know where it's headed. So they just kind of skip to the conclusion, which I'm okay with if you want to do that. So then you add 6 to both sides, you get x equals 6. Here you add 5 to both sides, you get x is equal to 5. And so we get two answers. So as I mentioned, you might be able to guess one of them by looking at the equation, but you might not find the other one, right? In this case, there's actually two. At least presumably there's two, because we have two results here. With square root equations, one aspect of that problem is that you have to check your answers. I'm not telling you that because it's just good advice, because we always say, like math teachers always say, check your answers, right? You have to in this case. It is a required part of the process of solving these equations, because this process has, how do you say? It has a loophole. I want to say loophole, but that doesn't really seem like the appropriate word there. This process has a flaw, has a potential flaw in it. Now, it's possible that these both work. In fact, I think they do. But there's also the potential that one of them actually doesn't work in the original equation. And the issue is the original equation was this: square root of x minus 5 equals x minus 5. This equation would not handle numbers smaller than 5 very well, because if I plug in a number for x smaller than 5, I would get negative numbers here, which means this would come out imaginary, so there's no way it would match the right-hand side. So what without getting into too much detail, what I like to point out with these equations is that there's a limitation. Square roots have limitations. But when you square both sides and get rid of the square root like we did here, that limitation is gone, right? So for this equation, I can pick a number less than 5 and nothing comes out imaginary here, right? There's no way to get imaginary results when it looks like this, but there are ways to get imaginary results when it looks like this. And so there is a fundamental difference between these two equations, even though we didn't do anything wrong, right? We squared both sides, we followed all the rules, but these two equations are not identical. This has limitations involving imaginary numbers, this one doesn't. And so our answers that we're getting could, how do you say, I want to say fall in the crack between these two equations, right? There's a slight difference between these two equations, and one of our answers could fall in that crack, that difference between these two equations. And while it might work in this one, in this version of the equation, it won't work in the original version, which is what we're trying to solve. Excuse me. So because this was the equation we're given, we want to find numbers that work in that equation. So what I can tell you about these answers is that they definitely are solutions to this equation right here, whichever one you want to look at. Because this equation didn't have any particular limitations. So any answers we're getting definitely work here, but it's questionable as to whether it actually works in the original equation because of that slight difference between these two. So I hope I explained that adequately. What it really comes down to, just to keep it as simple as possible, is you have to check your answers. That's really all I had to say about it, and probably all I should have said about it. So let's check our answers. We'll check x equals 6. Plug it into the original equation. We get square root of 6 minus 5 equals 6 minus 5, right? Which is going to give me the square root of 1 equals 1, which gives me 1 equals 1. So that one works. So 6 is good, but you don't want to automatically assume, well, if 6 works, then 5 must be the one that's bad. Because While that's probably the case a lot of the time, so when you get two answers from these square root equations, it is pretty common that one works and one doesn't, but it's not automatic. And so just because the first one works doesn't mean we can throw out the second one. We have to check it also. All right, so let's check 5. We'll plug that into this equation. So again, I'm going back to the original equation up there, plugging 5 in for x. You get this. We end up getting square root of 0 equals 0. The square root of 0 is kind of a weird one. A lot of students seem like they feel uncomfortable with taking the square root of 0, but there's no issues with it at all. Square root of 0 is 0, right? And so we get 0 equals 0. I don't know why I'm putting a box around it. I want to put a check mark, right? So 5 also works. So this is one of the more unusual cases where both solutions are actually valid. So you would type both of those into Math Excel. Sorry, I don't know why I keep having to swallow for some reason. Okay, now the example we just did was an equation with one square root, which is actually the nice version of this type of problem. This equation has two square roots. And for two square roots, there's actually an easy version and a hard version for that as well. So this one's going to be a lot more challenging. So having two square roots is a lot more work than having one square root. And in fact, I think I've said this for a couple different problems that we've seen in chapter 1, but this is one of the more difficult problems in chapter 1. But it's the easy version of having two square roots. There's a more difficult version of having two square roots. This one's going to be the easier of the two, but it's not easy. It's still a pretty difficult problem. So the first step, when you have two square roots to deal with, you can't. And so let me say what you can't do, because I get a lot of students that want to do this, and I wish we could. It would be so easy if this worked, but it doesn't. I'll get a lot of students that say, and not wrongly, that to cancel out a square root, I want to use a power of 2. But where they go wrong is they think, I'll just put a power of 2 on this one, a power of 2 on this one, and then I'll just square the 11. And they think as long as I'm squaring everything, it's balanced, so it should be okay for me to do this. But equations don't allow for this. You cannot square the individual parts of an equation, on the left-hand side and the right-hand side. It's all or nothing. Either you square the entire left-hand side or you don't square it at all, right? Same thing with the right-hand side. It's square the entire right-hand side, square the entire left-hand side. You're not allowed to split it up and apply that power of 2 to terms individually. It has to be applied to the entire left-hand side all at once. All right, so what we could do here, we can't do this. This is not allowed. We're not allowed to square the individual square roots. You could square the entire left-hand side all at once, but we talked about this on the last problem. You cannot distribute this power of 2 to each of these terms. And so this is not going to get rid of the square roots like you think. What you would have to do is do square root of x plus 10. Sorry, I'm doing the wrong thing here. Plus square root of x minus 1 multiplied to itself twice. And then you'd have to FOIL here, first, outer, inner, last. And I'm getting kind of sloppy there because it doesn't matter, because this is just not a good way to go. The square roots are not going to get canceled out. It's just going to be a big mess. It's not going to work out very well. So that's not the way you want to go either. So what you want to do here, let me just erase all of this and start over. The best path to getting the solution here is to get one of the square roots by itself first. So I usually like to get the scary one by itself first. So this one looks a little more scary to me. So I'm going to get this square root of x plus 10 by itself by subtracting the square root of x minus 1 to the other side. So isolate one of the square roots first. So we get 11 minus square root of x minus 1 on the right-hand side. Then square both sides. And you're going to do this in the proper way. You're going to square the entire left-hand side, square the entire right-hand side. Right? It's an all or nothing proposition. So square the entire left-hand side, square the entire right-hand side. And on the left-hand side, everything works out beautifully, just like it did in the previous problem, right? This power of 2 applies directly to this square root, so they cancel each other out, and we just get x plus 10. which is exactly what you want to see. The right-hand side does not work out so nicely, right? So the right-hand side, we're back in that same boat we were up here, which is, it's still better than what we had before, but it's still going to be some work. You cannot distribute this power of 2 to these two terms. You have to write it out, multiply to itself twice. If I can write it out. And then you have to FOIL. So this one I'm going to write a little more carefully since this is the way the problem has to be done. And we have to do first, outer, inner, last. Right. Go through the FOIL process. And the first one is the easy one, right? So we get 11 times 11, which is going to be 121. Then we get positive times a negative, which is negative. So I like to start by getting that out of the way first. And then we're going to have 11 times the square root of x minus 1. And those really don't interact in any way. They just kind of go next to each other. So when you multiply a number to a square root, the number stays outside the square root stays the same. They just kind of go next to each other, right? So we're going to have 11 square root of x minus 1. That's multiplying those two things together, and there's nothing you can do to really simplify that or make it look any different or better. The inner term, same exact thing happens. Negative times a positive will be negative, and then we have square root of x minus 1 times 11. So again, it's a number with a radical, and even though it's in a different order, the way we want to write it is to put the number first. So we'll put 11 first, and then square root of x minus 1 second. But it's really the same situation of they don't really interact with each other, so we'll just have to write them side by side, but we want to put the number in front of the radical. So we do have, and we have that option. We can, we can put it in either order, but it just looks better and is easier to work with if you have the 11 in front of the square root. Right, and then for the last one, it's a negative times a negative, which will be positive. And then we're going to get square root of x minus 1 times square root of x minus 1. Now, I've been accommodating with this situation when it was just numbers, maybe more than I should have. We actually encountered this situation here, right? And I actually just went ahead and used the shortcut here, but then I felt bad and I went back and I explained the details. But what you want to be aware of is that when you have a square root multiplied to itself, the square root goes away. It's a really handy shortcut to be aware of. Square root of 5 times the square root of 5 is just equal to 5. Yes, there's some details that lead us to that result, but you can just kind of take it as a fact that when you multiply a square root to itself, you just get whatever's inside the square root as the result. The square root goes away. Right? So in general, square root of a times the square root of a will just equal a. Now for numbers, if you don't want to use that shortcut, you don't have to. You can go ahead and multiply the numbers together and then simplify from there. But you really need to know that shortcut for this situation, because if you don't use it, if you decide to multiply these together, you get the square root of x minus 1 times x minus 1. Then you might FOIL that together, and then you're just going to be lost. You're not going to be able to get back to a point where you can solve this equation. Right? What you want to do here, instead of doing it like that, is to use the shortcut. Square root of a, let me try that again. Square root of a times the square root of a just equals a. In this case, we have x minus 1 instead of a, but it holds true all the same. Square root of x minus 1 times the square root of x minus 1 ultimately just equals x minus 1. The square root just goes away. That's the shortcut. And you really need that here. There's, like I said, if you try to do it the other way, it can go down a bad path that you'll never figure out how to get back on the right path. Even though there is a way, it's just really hard to find your way back. Okay? So use this shortcut. It makes the problem go much more smoothly. And it makes it less likely for you to get lost on the wrong path. Okay. So when you multiply these two together, you just get x minus 1. Right? Negative times a negative is positive. This times this is just x minus 1. This side is still x plus 10, so I just copy that down. And then the last thing we can do here is with the middle terms, since they're both the same exact radical, they are like terms, so we can combine them together. So negative 11 square root of x minus 1 minus 11 square root of x minus 1. You just add or subtract the coefficients, right? Negative 11 minus 11 is negative 22, and then the radical part stays the same. It's no different than doing negative 11y minus 11y, right? That's negative 22y. It's just instead of y, we have this radical, but it works the same way. We can also combine the 121 and the minus 1, and that gives me 120. And then the plus x just copies down. So it was kind of a mess, and the equation probably looks worse than it did at the beginning, right? It looks more complicated, like feels like we maybe went backwards, like we didn't really simplify things. Things kind of got more complicated, but we actually did make progress. And here's how you can know that. How many square roots did we start with in the equation? We started with 2. How many square roots do we have now? We only have 1, right? So that's progress. We got rid of a square root so that in such a way that we only have 1 square root left to deal with, right? We had 2 to begin with. We eliminated 1, and we worked things out in such a way that there's only going to be 1 left in our equation. So we can focus on getting rid of that one, right? So now the task is we have 1 square root left in our equation. Let's get rid of that square root now. How do I get rid of this square root? Get it by itself and then square both sides again. So again, the best way to get rid of a square root is to isolate it first, then raise it to the second power to cancel it out. So let's isolate it first. We'll start by subtracting the x, and this is why this problem is the easy version of the 2 square root problem, because these x's just cancel out from both sides. If that doesn't happen, if you still have an x outside the radical at this point, that's the hard version of this problem, and things get a lot messier. With the x's canceling out, things actually go quite smoothly from here. So we're going to subtract the 120 to the other side as well, and you'll see how simple of an equation we end up getting. So I'll get negative 110, right, when I combine these two numbers together, equals negative 22 square root of x minus 1. We're still trying to get the radical by itself, so I want to get rid of the negative 22. It's being multiplied to the radical, so to get rid of it, I would have to divide by that number. And sometimes you'll get a fraction here. I won't lie to you. Sometimes you divide by that number and you end up getting a fraction that you have to deal with. But this one works out really nice. We get 5, right? 5 equals the square root of x minus 1. So you see the equation comes out really, really nice and simple in this case, right? Now to get rid of the square root, we will square both sides again. And we'll get 25 equals x minus 1, right? The square root cancels out the power of 2. And then we can solve this for x by adding 1 to both sides. And we get x is equal to 26. So that was a lot of work. Like I said, one of the toughest problems in the chapter, in my opinion. And even after all that work, we're not done. Because what did I say on the last problem? We have to check our answer. We can't trust that answer, right? Because the original equation had certain limitations that we eliminated when we squared both sides, right? When we get down to here, there's no limitations. So we might get an answer that works in this equation that doesn't work back when the equation had certain limitations. So we have to check our answer. It's not advice. Now, if you're working on Math Excel on the online homework system, you can kind of cheat and let the homework system check for you, right? So I could just plug that in to my homework assignment, plug in 26 into the box, and let it tell me if it's right or wrong. But then if it's wrong, you don't know if it's wrong because it doesn't work in the original equation, and so therefore there's no solution, or if you just made a mistake and got the wrong number when it should have been something else. So you'd have to go back and still double check your work anyways. So you're better off just checking your answer, right? And so go back to the original equation. I'm trying to remember what it was. X plus 10, square root of x plus 10, plus the square root of x minus 1, and that's supposed to equal 11, I think is what it was. All right. And let's plug in 26 to see if this works. All right, so we get 26 plus 10, and then I put 10 for some reason. Why did I do that? Let's try that again. 26 minus 1 is what I was supposed to plug in. All right, so we're plugging in 26 for x. And we're going to get the square root of 36 plus the square root of 25 equals 11. Square root of 36 is 6. Square root of 25 is 5. 6 plus 5 does indeed equal 11. And so this answer is good. And so 26 is the solution. If that answer didn't work, and we're certain we didn't make any mistakes, and 26 doesn't actually work in the original equation, then the equation would have no solution. So that's how you would know if there's no solution to these equations, is you would solve it and you get an answer that doesn't actually work in the original equation. And nothing, and so I should say not just one answer that way, but if all of the answers you get here do not work in the original equation, then you know that original equation has no solutions. All right, that's how you would tell. All right. So here's another kind of equation, different from the ones we've done so far. And this is called a rational exponent equation. So it's a pretty simple looking equation, but there's kind of a lot of details that are hidden by this. But we have an exponent that's a fraction. That's what rational exponent means. Rational means fraction, and then it's in the exponent. And it's a really simple, the approach, the strategy is pretty simple here. The strategy is just raise both sides to the reciprocal power. Right, so for negative 2/3, that's our fraction in the exponent. The reciprocal is negative 3/2. Now notice the reciprocal is also negative. Many students make the mistake of thinking the reciprocal of negative 2/3 is positive 3/2. But I think they're confusing that with perpendicular lines, which we talked about in section 1.4, right? The slopes for perpendicular lines are negative reciprocals of each other, which means they're flipped over but also opposite sign for them to be perpendicular, right? That's what the slopes would have to be. But we're not talking about slope here, and I didn't say find the negative reciprocal of this number. I just said find just the reciprocal. And if you're only doing reciprocal, the sign stays the same. The sign doesn't change, right? All you do is flip the fraction over. That's all you have to do for reciprocal. And that's all we want to do here, right? And so we're going to take the left-hand side and raise it to the power of negative 3/2, right? That's the reciprocal. If I do that to the left-hand side, got to do the same thing to the right-hand side. On the left-hand side, what happens? When you have one power raised to another power, you multiply these together. And when you multiply a fraction by its reciprocal, everything just cancels out. And even the negatives. This is why it was important to keep the negative here, because negative times a negative cancels those out and makes it positive, right? So all of this stuff goes away, which means we really just end up getting a 1 there. We get x to the first power equals 9 to the negative 3/2 power, which you can just plug into your calculator, which is what a lot of students do. But I do like to talk about what is actually happening here. So when you have an exponent that's a fraction, the numerator is a power. So we're raising this to the third power. Oops, that was kind of a weird E there. Let's try that again. Third power. The denominator is a 2, and that means you're taking a second root, which really is just a square root, right? So a second root, we have a special name for that, square root. So you have to do both of these things. And also the negative sign here does something as well. So there's a lot of interpretation that has to go on to evaluate this based on the exponent that we have. But essentially the numerator is a power, the denominator is a root. The negative sign means we want to flip this over into the denominator. So that's really probably the first thing we should do. So x to the first power is just x. This becomes 1 over 9 to the 3/2 power. So by flipping this down to the denominator, that accounts for the negative sign, so the negative sign goes away. Then we have to raise this to the third power and take the square root, but we decide the order for that. And if you raise it to the third power first, you get 9 to the third power, which I'm not even sure what that is. I think, actually, now that I think about it, I think it's 729. It's huge. And then you take the square root of 729. Well, I'm not sure what that's supposed to be, right? You can do it in the other order. In fact, that's going to be a lot easier in this case. So what I'm going to do is take the square root first and then raise it to the third power, right? So I'll take the 9, do the square root first, which is going to be 3, and then I'll raise it to the third power, which gives me 27. And so I'll get 1 over 27 here. All right. Now, when you go to type that in the Math Excel, it won't be correct. You won't get the right answer from that. So Math Excel is going to say, sorry, you're missing something, or just flat out, you have the wrong answer. I'm not sure how it might respond. And the reason is, as I mentioned, this denominator of 2 means you're taking a square root. Now, if you go back a step, notice you did that to both sides of the equation, right? There's a 2 in this. So when you did this to both sides of the equation, what did you do to both sides? You actually took a square root of both sides of the equation. You did it in a hidden way, right? So by raising both sides to the 3/2 power, you are actually applying a square root to both sides, even though you weren't using the square root symbol. It's still what was mathematically happening. And what did we learn in the last video in section 1.5? When you take the square root of both sides, you have to do plus or minus. So be very careful about that when you're solving equations with exponents. If the denominator is a 2, you are taking the square root of both sides. So you have to be aware that the denominator of 2 means you're taking a square root. So even if you decide, I'm just going to plug this in my calculator, I'm not going to worry about interpreting it, you still need to know that denominator of 2 means you're taking a square root of both sides of the equation. So because of that, you should have a plus or minus on your answer. So the correct answer that you should be typing into Math Excel is plus or minus 1 over 27, which means there's 2 solutions, positive 1 over 27 and negative 1 over 27. All right. So here is another type of equation. And this one, we are faced with a fairly complicated looking thing here, but the idea, and the reason I chose this one, because I think it's easier to see. And I wonder if there's a way that I could do this so that it, I don't know. I'm trying to think of a good way to mark this to make it easy to see. But if you kind of ignore what's in the parentheses, I can't think of it. I could use a shape, right? I think I could use a shape. Let me see. I think there's a shape drawing tool somewhere on here. I don't see it anywhere though. I thought there was. See, is it on here? No, that's not it. Sorry, I guess I should know my own software. I could have swore there was, but I don't see one anywhere. If I could draw like a circle or a triangle or a square or something, that would help, but I don't. Oh, maybe it's right here. No, that's not it either. Oh wait, yeah, there's shapes. Well, this is kind of a pain though, isn't it? Okay, so let's do a blue dot. Can I make this bigger? All right, okay. So cover up, oops, it didn't like that for some reason. Cover up that expression with a blue dot. And do the same thing. I want another blue dot. Can I copy this? Let's see. Yes, okay, perfect. Okay, but it doesn't like me moving it for some reason. Okay, there we go. Cover this up with a blue dot too. Now the reason we can do that is because it's the same thing under each blue dot, right? Now if these were 2 different expressions, I would need to use 2 different shapes. But because they both are 3c minus 3 over 8, it makes sense to cover them up with the same shape. And what you can do is actually just think of this as like a new variable. So let's say the shape has the label x. Well, maybe I shouldn't use x. The common substitution letter that gets used is w. That's a really common one. So let's use w here. What you don't want to do is use whatever variable's already in the problem. All right. So let's label each circle as w. So we're just putting a label on the circle. But if you think about that label on the circle, which is, again, covering up the same thing in both cases, and read the equation with that label instead, what you have here is w squared plus 3w equals 10. And now instead of being this crazy, equation with parentheses and fractions and whatnot, it's just a basic quadratic equation. By covering up what's inside the parentheses with a w circle, we get this nice equation with w. W squared plus 3w equals 10. which we can solve. We can solve for w. So remember, it's quadratic. To solve it, we have to get it equal to 0 first. So we get w squared plus 3w minus 10 equals 0. Then you factor it, which I'll just do up here, I guess. What two numbers multiply to negative 10 and add to 3? Positive 5 and negative 2. Then you can set each factor equal to 0, so you get w plus 5 equals 0, w minus 2 equals 0. Then you can solve for w. And you get w equals negative 5 and w equals positive 2. So you solved the equation, right? And because you've solved it, you want to type this answer into Math Excel. And so you type in negative 5 and 2. Now, if Math Excel was an AI of some type that could respond to your work, which maybe isn't so far off in the future, so maybe math teachers will become obsolete as these homework systems develop artificial intelligence and can actually respond back to the work you're doing. But if you could, let Math Excel see this work, it would say, or if you would just type in the answer, w equals negative 5, w equals 2, Math Excel might respond with, what is w? What are you talking about? I gave you an equation with c, and you're telling me w is equal to this. And it might be confused by that choice, right? Math Excel didn't give you w. We introduced that into the problem. W was our invention. And Math Excel wouldn't even be aware of what you mean by w, again, unless the artificial intelligence gets smart enough to realize it, right? So this is not the final answer because we weren't looking for w. We were looking for c, right? That's the value we're looking for. So if you were to move, oh, that's not going to work. Okay, maybe I can't. Oh, no, here we go. This is what I want to do. Move the circle back out of the way. Underneath the circle, underneath the w, is 3c minus 3 over 8. Right? And that's what we had here in the original equation, but it's still true over here, right? So these circles really followed along with the w. And when I remove these circles, what's underneath the circle is the same thing that we have underneath the circle here, right? 3c minus 3 over 8 is what we see underneath the circle. So what we need to do is take the w back out. So again, I like to say, when I'm talking about this in class, I'll say, think of w like a mask, right? It's covering up this bad part of the equation. But once I'm done solving the equation, I take the mask off. What's underneath this mask right here? It's 3c minus 3 over 8, right? That's what's underneath the w circle. And that's what we need to go back to because Math Excel wants to know what is c equal to. So we can't stop at w equals negative 5. We need to stop at c equals something. So we remove the w from our problem. Now that we're done solving the equation, put c back into the problem and then figure out what c is equal to, right? So it's going to look like this. So this is called solving by substitution. We have what's called a quadratic-like equation. It has the structure of a quadratic equation, but it's not exactly quadratic. But by doing a clever substitution, we can turn it into a quadratic equation, which is what we did here. And then you can solve it as a quadratic equation, which is what we did here. But once you're done solving it, once you've used w to solve the equation, you're done with w. You take the w back out, you go back to the original expression that w replaced. All right, so I hope all that makes sense. So this is what we end up getting. Now that means more work to do, right? Because now I need to solve this for c. So to get rid of the 8, since we're dividing by 8, to cancel it out, I'll multiply by 8 on both sides. I get 3c minus 3 equals negative 40. And be aware that when you multiply a number to a fraction like this 8's going to cancel out with this 8, and it's gone. It doesn't also get multiplied to the top. So I'll get a lot of students that cancel out the 8's, but then also distribute the 8 up here. You can't do both. You have to pick one. Either you let it cancel out or you distribute it. You make the choice, but the best choice there is to let it cancel out. Right? And then you add 3 to both sides. And so we'll get 3c equals negative 37. And then we divide by 3. And we don't get the nicest answer here, but that's okay. We get c is equal to negative 37 over 3. And then Math Excel is going to say, okay, now I know what you're talking about. C is equal to negative 37 over 3. That is correct, right? Do the same thing here, same steps. So in fact, I'll just kind of skip those steps because I think I can see what's going to happen. We'll get 19 over 3. So I'll leave those details for you. But it's the same exact steps. Multiply 8 on both sides, add 3, divide by 3, and you'll get to that point. Okay, let's move on to the next problem. So here we have two absolute values, and then the last page is a bunch of different examples based on the problems that we saw earlier. So if this was in a face-to-face class and we had time left in class, I would stop and say, okay, you guys try these problems, and then I'd put the answers on the board so they could check. So what we'll do for this video is I'll just pause my recording, I'll work out the problems, and I would ask you to pause it as well, work out the problems on your own, and then resume the recording, and you can see what all the answers are to see if you had the right idea. But before we get to that, let's go ahead and finish this problem here real quick. So when you have two absolute values, now we saw absolute value equations back in section 1.1, but this one has two absolute values. So how does that change the game here? It actually doesn't. So you actually handle this the same way you would if there was just one absolute value. You're going to split this up into two different equations. The first one will be an exact copy of the original, but without the absolute value. So I just copy this down, but with no absolute value. The second equation, the left-hand side stays the same, but I take the negative of the right-hand side. Now you do have to be a little careful with this because it's going to be different than what we had to do before. It's not really different than what we had to do before, but it's going to have a different feel to it because we are taking the negative of something that has two terms. We have to put parentheses around that. So that's one difference with this kind of problem, is that because there's multiple terms there, you have to make sure you use parentheses, which is something you didn't have to worry about with the previous problems we were doing because it was just a number. But when there's an expression there, you got to make sure the negative sign gets distributed in that expression. So, which we can just go ahead and do. So distribute the negative sign here. You get x plus 9 equals negative x plus 6 is what you should end up getting there. Let's just finish this one out. So we add x to, so now you solve this for x. Now that absolute value is out of the way, we add x to both sides. We might as well go ahead and subtract 9 from both sides. So we get 2x is equal to negative 3. We divide by 2 on both sides. We get x is equal to negative 3 halves. So that's what you get from the second equation. From the first equation, you go to solve for x by subtracting x to the left-hand side. And what ends up happening is the x's just cancel themselves out. So we get 9 equals negative 6, which, because x is gone, there's no solution now, right? Well, I shouldn't say because x is gone, there's no solution. When x disappears, and we talked about this in section 1.1 as well, when x disappears from your equation while you're trying to solve it, that means it's a special case. And either there's no solution or there's infinitely many solutions, right? It could be either one. The way you tell is whether this comes out true or false, right? Now, 9 equals negative 6 is false, which tells me that this equation provides no solutions. That doesn't mean the entire problem has no solutions, because we had a second equation which did give us an answer. But this branch here, well, I did a really bad job of dividing that. This branch right here produces no solutions. And so we get nothing out of this one, but we do get an answer out of this one, and this one's still valid. This is still a valid solution. So in Math Excel, your answer would be there's one solution, and it's negative 3 over 2. So this would be our final answer here. So x equals negative 3 halves would be the solution to this equation. This didn't give us anything to add to that, so we just only have the one solution. Okay, so let me go ahead and pause the recording. You do the same. And then when you resume, and so however long it takes you is fine, but when you resume the video, you should be able to see all the answers to these problems, and you can check to see if you got them correct. If I'm your instructor and you didn't get one of these correct and you have a question about it, please feel free to email me, because I think what I'm going to do, I already recorded a video earlier. I'm getting kind of tired now. It's getting close to dinner time. I don't think I'm going to take the time to explain each individual problem. I'll have the work there and the answer, and so you can look through the work, see what the answer is, but if it's still not clear to you, please let me know. Okay, so go ahead and pause it and work on these problems. Okay, well that took a little bit longer than I expected it to, and I don't know what I was thinking. I just thought I would just show the answers on the screen real quick and be done, but especially that problem in the bottom left-hand corner took quite a long time and a lot of space to work out, and I'm sure if you try that problem, you notice that as well. So again, I'm not going to go through these problems in detail, but I do want to take the time to scroll through the work that's on the screen so that you can pause it and check if necessary. The solutions I got for the first problem here were x equals 216 and x equals -1. And here's the work for that using substitution. I tried to use the circles again so you could kind of follow along with that. For the second equation over here on the right-hand side, you take the reciprocal power. Remember plus or minus because the denominator here is 2, so we're doing square root to both sides. This one, I talked about doing these in whatever order you want, and oftentimes you want to do the root first before the power, but taking the square root of 2 doesn't really do anything. You can't simplify the square root of 2, so I decided to do the power of 7 first and then take the square root second. So 2 to the 7th power is 128. Then you take the square root of that by splitting it up, and you're able to simplify it down to 8 square root of 2. For this problem with the 2 square roots, that was a really tough problem. So this one is the hard version of the 2 square root problem. We did the easy version earlier, but there's no such thing as an easy problem with 2 square roots. They're both difficult, but one's easier and one's more challenging relative to each other. So here you have to get a square root by itself. So you get the scary one by itself first. That's what I usually do. Square both sides. You're going to have to FOIL this side out. This is all the details for that. And why this one's the more challenging version is because when you reach this point, you now need to isolate this square root. You subtract the x over here, but the x's do not cancel out. In the example we did earlier, the x's canceled out. That's the easy version. When the x's don't cancel out, that's the hard version. So you're stuck with this expression. I still recommend dividing by -4, even though this is going to not cancel out very nicely. So you end up with this fraction, which I could have taken the time to reduce. Maybe I should have. It might have made things a little bit easier later on, but you don't have to. So I just kind of left it the way it was. Get the square root by itself, square both sides again. And so I come over here. I don't know why I did that, but I moved my work over here. When you square a fraction, you just square the top and the bottom separately. That's all I did here. And then -4 squared will be +16. This, you cannot distribute the power of 2. You have to write it out multiplied to itself twice. And then you have to FOIL, which is what I'm doing here. And while I'm kind of doing multiple things at once, I'm starting the process for FOILing here. At the same time, I'm getting rid of this fraction by multiplying 16 to both sides to cancel out that denominator. And then when you multiply it to the right-hand side, because there's 2 terms here, you have to distribute it. You have to put parentheses here and then distribute it to both of those. And even though I didn't reduce it earlier, these numbers were a little bigger than they needed to be. But in the end, it's not too much of an issue because a lot of things cancel out here. So you end up with just this. It's quadratic, so you solve it by factoring. But this, all you can do to factor it is factor out the common factor, which is 4x. And then you set each factor equal to 0. Notice I don't use the 4 here because the 4 is a factor that doesn't have a variable with it. So the 4 is not going to give you anything useful. So I just set the x equal to 0 and the x plus 4 equal to 0. And when you solve that, you subtract 4 from both sides, you get x equals -4. So again, I skipped a little bit of detail there in my work, but ultimately you get -4 as your solution there. And then even after all that ton of work, which took me like 15 minutes, I'm sure it took you just as long or longer, you have to check these answers. You cannot trust them. These are potential solutions. If there are any solutions to this equation, it has to be one of these two or both of them. But these are the only possible solutions to the equation. But you have to check because you don't know for sure if they work or not. And it turns out that 0 actually doesn't work. So I go back to the original equation. I plug 0 in for x. I end up getting this, which gives me 6 equals 2. So the left-hand side doesn't match the right-hand side. So I have to throw 0 out. I check -4, plug that into the original equation. That one actually ends up working. You get 2 equals 2. That's true. So -4 is a solution to the equation, but 0 is not. So the only solution to that equation was -4. For the last equation over here on the right-hand side, it's a little bit easier. It's just one square root to deal with. So the first thing is to get that square root by itself. You subtract the 8 over to the other side. Then to cancel out that square root, you square both sides. You're going to have to FOIL this. Then it ends up being quadratic. So you have to get You have to get it equal to 0. Now I said you have to be careful because sometimes it's linear, sometimes it's quadratic, but I feel like every example I've done, it's come out quadratic. And to solve a quadratic equation, you get it equal to 0, then factor the other side. So I subtract the 2x over here, factor this, set each factor equal to 0. This gives you x equals 8, x equals 2, but then you can't trust those answers because anytime it's a square root equation, you have to check your answers. 8 works, so I go back to the original equation, plug in 8 for x. It works out, you get 12 equals 12. 2 does not work. You plug in 2, you end up getting 10 equals 6, so it doesn't make the left-hand side match the right-hand side, so the equation is false when you plug in 2 for x. So you throw that one out, and 8 is the only solution in this case. So that is how those 4 problems should have worked out for you. If you have any questions, and if I'm your instructor, please feel free to contact me and let me know. Otherwise, I will see you in the next video for section 1.7.